and tan. Toa. Op over adjacent. That's what we're bringing to the party. That is our prior knowledge. Now, let us apply that knowledge. What do I have here? I have this crossy thingy, plusy thingy. What is that really? That is x and y. You know it as the coordinate grid. It is also, it used to have the name Cartesian plane because it was named after the guy that invented it, who was René Descartes. But he was a white French mathematician, and other people also invented this at a similar time. So we have changed its name to coordinate grid because lots of people used it, not just René Descartes. But some of you may have had a math teacher that called it the Cartesian plane as opposed to the coordinate grid. If that is the case, they are the same thing. Now, you have all brought prior knowledge to the party of this construction here, right? Of course you have. On the x-axis, what are all of these numbers out here? Positive. What are all these numbers out here? Negative. On the y-axis, what are all these numbers up here? Positive. What are all these numbers down here? Negative. Now, so far, we have done all of our trigonometry when all the values have been what? Positive. Which means all the trigonometry you have done is living in this quadrant, which is quadrant 1. Because in this quadrant, every value is positive. Right? Everybody gets it, yeah? Now we are not yet going to go beyond 90 degrees. We're going to stay with 90 degrees. But we are going to introduce some new stuff here. So this is quadrant 1, where all the values in quadrant 1 are x and y, and they are both positive. We're all comfy cozy with that, right? Okay. Over here lies quadrant 2. In quadrant 2, all the values are once again x and y values, except what is the difference? X is negative and y values are positive. Right? Finish the drawing. Quadrant 3 and my good friend quadrant 4. I should have written it down here. You people finish that drawing up, put in the information. I will wait a second for you to do so. Why? Because I care. And of course, this is again xy, but they are both negative. And our orange buddy over here is again xy, except it is positive and negative. And everyone's cool with that, right? Yeah. Okay. Everybody, and I use the pink for that, everybody put a line, and I want to keep the colors as similar as I can. Put a line there. Is that an angle yet? No, of course not. It's just a line, right? What makes it an angle? It needs a vertex, right? Okay. So let's give it a vertex along the x-axis. Now is it an angle? Yeah. Is it something I can do trig with yet? No. Why not? Because I need a third side so I can do opposite hypotenuse, adjacent, opposite, adjacent hypotenuse, yes? All right. So now we're in business, yes? Everybody cool? Here is our theta. Everybody good? All right. Now, remember when we were talking about directions and we started counting at north, right? Well, in math, we don't start counting at north. Problem 1. Problem 2. In directions, we counted clockwise, yes? 0, 90, 180, 270, right? In math, we count counterclockwise. Or if we were in Britain, we would count anti-clockwise, which is sad because Uncle Clockwise then is bothered. I'm not going to draw again until I hear some more laughter. That's better. Okay. All right. So this angle is measured this way. All right? Clockwise from the X. I forgot the H and the E. Clockwise, and now it won't erase. Clockwise from the x-axis is positive. And my pen, maybe it will save itself. Now, you're intelligent young people then. What, therefore, must be the values if I were to go, counter clockwise from the x-axis is positive? What would be the value if I went clockwise? Negative, of course. Yeah, I wrote clockwise, but we count it counterclockwise. In directions, we count clockwise. In math, we count counterclockwise or anti-clockwise. I screwed up because I was doing the joke. It's Monday morning. Leave me alone. Counterclockwise is positive, which of course means clockwise is negative. Everybody cool? All right. So we could do all the trig we wanted to do, we could possibly do with that pink triangle right now, yes? Now you're intelligent young people. If you can do trig on that triangle, could you do trig on this triangle? Yes, of course you could. Because it's the exact same thing, isn't it? You don't know how to do it yet, but you're going to learn. But everybody understands, if trig works in the pink triangle, it must work in the blue triangle. Because it's still a right angle triangle, right? Okay. So we're going to not do any trig yet. We got to do some, what's that word? Vocabulary. Let us begin with the first piece of new vocabulary. An angle is in standard position if my pen keeps dying. If the vertex is on the origin. Now, we all remember what origin means, right? The origin is right there. I'm going to put a little green circle there. I'm going to highlight it. The vertex is, of course, the corner, right? The vertex is on the origin. And this is going to be another new word for you, the initial, that's supposed to be an N, ray. I'm going to highlight that in yellow. Highlight that in yellow. Well, I'd try to highlight in yellow, but I got a bunch of yellow dots. is on the positive x-axis. The other ray forming the angle, because remember, unless you have two rays, you don't have an angle. By the way, everybody knows what a ray is, right? It starts from a single point and goes forever in one direction instead of both directions. That's a line. The other ray forming the angle is the terminal arm or terminal ray. And I will highlight that. What color have I not used? That is see-through. Pink. That's up there. Is everybody cool? If those two things are happening, you have an angle that is in what we call standard position, and we can do some trig. Stop it. Counterclockwise rotation, positive or negative angle? Positive here. Clockwise rotation, negative. Is everybody good? Yeah? Okay. So, if I were to put... No. That's where we're going to stop for now. Turn the page over. You don't have a protractor, so you are going to sketch the following angles. All right? Remember, where do we start counting now? We don't start counting at north. Where do we start counting? Right here. Are all these positive angles? They are, right? You don't see any negative signs. So what direction will we be rotating? Counterclockwise. Or if we were in Britain, anti-clockwise. Everybody cool? Sketch me 6 angles. Go. What a dumbass. Everything I just said in class applies to here. You guys have to pretend it's like 2014 where you actually had to remember stuff. Not 2019 where it's all remembered for you. So now I'm going to record how you draw these, and then that'll apply back to the thing I forgot to record, so it'll all work. It's cool. No problem. R and theta in the same spot. What does R equal? $60. $250 There's r, and what does r equal? 70. Okay, I'm a little confused as to why I'm getting so many different answers, especially when we wrote it right here. Yeah. This is a better one. It's 270. Yeah. Sorry. That should not be there. And then in green, 350. R is there, and what does R equal? 10. Now, R is 10, but that terminal arm is also at negative 10 degrees. Does everybody understand that? Okay, your reference angle is positive because it's 10 degrees. Okay. Turn the page over, and we're going to make a slight change to things. We are going to bring grade 9 use of the coordinate grid. We are going to bring it into grade 10 here. So, draw the angle if the point P, this point, is on the terminal arm, which means that the terminal arm must do what? If that point is on the terminal arm, then what do you know the terminal arm does? I appear to have asked a confusing question. Henry? Yeah, it goes through quadrant 1. So if it's a terminal arm, it must start here, and it must go through that point, which is out 1, 2, 3, and up 1, 2. Go. I gotta stop pausing. I just gotta let it run. I just pause it for you people so you don't have to, sit there and skip the 5 minutes while you're doing work, and then you go a little too far, then you gotta pull back a little, then you go a little too far back, then you gotta go a little forward. You know that thing that you all do on YouTube because none of you have the patience to actually watch a whole YouTube video? Alright. Alright. Not that any of you watch YouTube, for me. I mean, I have the analytics. One view is a stellar night. One day I'm going to make a chart where I have amount of views of a video and then questions asked about stuff in the video the next day. And I will find that one view, 25 questions. But that's okay, because I will continue to do it, because I am insane. All right, so, bunch of white space, what's it there for? Not notes, but little tricky bits, yeah? So, remember, if I tell you theta equals negative 70, where will that be? Right there, yes? How big is the reference angle? It's the same, it's 70. How big is theta? No. Theta goes that way. So what is it? Which is? Theta is 290. Everybody is good? Everyone is good? All right. Well, then I guess I don't need any more of that white space if everyone's good. When you turn on to the next page, you will see textbook work that I somehow have forgotten to provide you with the answers for. No big deal. You're going to work on it in class. You got 26 minutes. Most of it, the whole second one is multiple choice. And the hardest thing you have to do in this for this whole section is add or subtract from 180 or 360. I'm hoping that the best and brightest in the whole school can do that addition and subtraction without having the answers. Hazel? And you still put your hand up, so I will answer whatever question you have. Maybe you're going to ask me a question about the Holy Roman Empire. Maybe you're going to ask me a question about the James Thurber short story, The Secret Life of Walter Mitty. I don't know. But whatever it is, if I can answer it, you know I'm going to answer it. So, Hazel, what?
We have our thing here, and let's say our theta is 90 degrees like this.
Yeah.
Then is our reference angle correct both ways?
What's the value of the reference angle? 90, either way, right? Okay.